Hi, it's Ms. Molesbury here. This video is going to help you think through some of the toughest questions on the Progress Check 313 to 315 over polar functions. So you'll notice as I go through this video, pretty much every question is from 314 or 315. 313 was just more of the basics. Do we know how to write polar coordinates in equivalent forms, convert from polar to rectangular, and vice versa? So if you were missing any questions labeled, go back and look at 313, I think you can do that. Go back to your notes, go back and rewatch the video if you need to. Those are all more formula-based thought processes, where when we get to 14 and 15, there's just a little more analysis going on, so that's what made me pick these questions. Of course, feel free to fast forward depending on if you need help with this question or not. Mine are in a random order, as yours were, with random order answer choices, so you will have these questions, just not in this exact order. All right, let's take a look. Also, I apologize, I don't know why mine looks this spaced out, but you can read it all just fine. I was screenshotting it from my iPad. So here we go. It says the polar function r equals f of theta, where f of theta is 2 minus 4 times sine theta, is graphed in the polar coordinate system for our radians between 0 and 2 pi, and those are included. On which of the following intervals of theta is the distance between the point with polar coordinates f of theta comma theta and the origin decreasing? Okay, so let's see what this question's asking. We're given an equation, which is great, and we're trying to find which of the following intervals of theta, so we're looking at our angle, and we want to know when is the distance between the point and the origin decreasing. So from lesson 315, we said that we can determine this a couple of ways. We're going to know that the distance, I'm going to look at the second box, the distance between the function, this polar function, and the origin is decreasing if the function is positive and decreasing. So we have positive r values that are getting closer to the pole, or if the graph is negative but increasing. So negative r values, but if they're increasing, they're getting less negative and therefore closer to the pole or the origin. So this can be seen, of course, in our polar graph. If we were provided a graph, we could try to analyze that, but it's going to be easier to see from the rectangular form of the graph. And we are going to be better at graphing it. It's going to be faster if we take this function 2 minus 4 sine theta, and just try to draw a sketch, right? This has shifted up to, so that's going to be our midline of y equals 2. We're not forgetting everything we learned back in, what was that, 3.4, 3.5? Okay, so I'm shifting up to. I have an amplitude of 4. So if this is 2, it means my graph will go up to 6 and down to negative 2. Get rid of that, it makes it look like a negative. There we go. And then we have a sine-shaped curve, but it is reflected, so that means it's going to go down to its minimum before coming back to the midline and the maximum. The period is 2 pi. So let's just do general shape first. I know we'll make it back to the midline at pi. We'll reach our minimum right between that, our maximum right between pi and 2 pi. And I'm just going to draw a sketch. Right, and then back to the midline by 2 pi. So this is just one period of the function, but that's all we need because the period's 2 pi here, and it told us we're looking at our radian measures from 0 to 2 pi. Great, so we care about when this graph is positive and decreasing, or negative and increasing. And it would be nice to know, okay, where are these x-intercepts? Because that's where the graph changes from being positive to being negative. And also, if we think about them from the polar perspective, our x-intercepts show us when the function returns to the pole in our polar grid. One thing I was going to say too, so far I haven't done any like algebraic calculations, right? This sketch is just made from what we know of the period of sine, the shape of sine, and then the couple of transformations we saw from the equation. And let's talk about x-intercepts. We know how to find them. Let's find the zeros by setting this equation equal to 0. So I'm going to subtract 2. Divide -2 over -4 will reduce down to a half. And then we're thinking about when is sine a half. And on our unit circle, we know that happens at positive pi over 6 and 5 pi over 6. And so that's going to reveal to us these two x-intercepts where the graph changes from positive to negative. So pi over 6, 5 pi over 6. Okay, great. All right, I think we have all the details we need. Let's go look for when the function is positive yet decreasing. So it looks like that's going to be the very beginning of the function. And then again at the very end. And then if I look for where the function is negative but increasing, so below the x-axis but getting closer to the x-axis, I have one section here, and there's no time, oh, that was it, right, negative but increasing. Okay, so now I have to determine out of my answer choices, are any of these choices what we just highlighted? So 5 pi over 4 to 3 pi over 2, that's going to be right here between pi and 3 pi over 2, not a highlighted region. I'm going to eliminate that choice. Of course, this one I did already have the answer kind of picked here. We have 5 pi over 3 and 11 pi over 6. Even though those are not two values that where the graph changes direction, they definitely lie between 3 pi over 2 and 2 pi. So that's what I had chosen on my iPad before I took the screenshot. Let's check the other two. Pi over 6 to pi over 2, we can see that's the piece of the graph below the x-axis where the graph is decreasing. So I'm going to cross that out. And then at the end, 5 pi over 6 to pi, that's this little piece right here just after our x-intercept, not highlighted. So I'm going to go ahead and get rid of that. So the only choice that remains is 5 pi over 3 and to 11 pi over 6. That was a lot of work, and thankfully most of them don't require this much work, but like this is the way to know 100% we are picking the correct answer. Of course, you could try to test different values in these intervals, but some of that's going to be actually more difficult, right? What are you going to test between 5 pi over 6 and pi? So you're going to have to make a graph, not on all the questions, but this one definitely required it. We'll talk about on the future ones if we could just test different values instead. This is also, this table, going to be really important that you know and understand for your test. It will not be provided, but remember if you think about these moving the same direction, like the radius is positive and increasing or negative and decreasing, that's going to make the distance increase overall. This will come up again. We'll talk about it again here in a question or two. So here's the next one I picked. It says the figure below shows the graph of r equals f of theta, where f of theta is 6 times cosine of 2 theta in the polar coordinate system, r radians between 0 and 2 pi, and there are 4 points labeled A, B, C, D, and E. If the domain is restricted from 5 pi over 4 to 3 pi over 2, which of the following describes the portion of the given graph? All right, well, let's think about what we know about polar functions. we know that our input is our radian measure, so let's focus on this piece of the graph. So 5 pi over 4, zoom it in a little bit, and 3 pi over 2, and 5 pi over 4 is the exact middle between A and D there. There we go. So we are looking at this piece right here in quadrant 3. So let's talk about if we could eliminate any answer choices at this point. So this says, is it the portion of the graph in quadrant 4 from D to E, the part in quadrant 3 from E to D, the part in quadrant 1 from E to B, or the part in quadrant 3 from A to E? I think after tracing those, there are a couple that we can go ahead and cross out. So for these radians here, it's either going to have to create from the origin positive radius lengths that are getting closer in the direction of 5 pi over 4 and 3 pi over 2, or if our R values are negative, then they're going to be behind and send negative R values into quadrant 1. So for this reason, I want us to cross off quadrant 4. It's not possible that radians in quadrant 3 can create pieces of the graph in quadrant 4. Also from tracing A to E, this piece here was not something that I could have created from the radians 5 pi over 4. Like the radius length would not have been heading in that direction or the opposite direction from those radians. So I'm going to cross off A to E. And then let's just decide, is this in quadrant 1 or 3? So you have a choice. You could sketch the rectangular graph like we did on the last question up here, or you could try testing a point. So we could either test one of these quadrantal angles, or maybe you want to test something between. I'm going to choose to test between them at 4 pi over 3. So if I do f of 4 pi over 3, 6 times the cosine, we have 2 times 4 pi over 3 here. A little annoying, but we can handle that. So now I'm getting a radian measure, 8 pi over 3. That's bigger than 2. So let's figure out what's coterminal from 8 pi over 3. So I'm just going to do a quick 8 pi over 3 and subtract 2 pi, which I'm going to write in terms of thirds. Okay, so 8 pi over 3 is the same place in the unit circle as 2 pi over 3, coterminal. And if we're talking about the cosine there, let's see, 2 pi over 3 is negative half, positive root 3 over 2. But we need the cosine, so 6 times negative 1/2. So we would get negative 3 when our radian measure is 4 pi over 3. So that means that these points here are going to actually give us negative radius lengths. I could go ahead and find that value at 4 pi over 3. So now I'm doing more work than you probably need to, since we know it's in quadrant 1 now. But we just found this point, negative 3 at 4 pi over 3 as our input. So that shows me that it's going to be the piece of the graph from E to B in quadrant 1. If you wanted, you could also, of course, have tested the endpoints if you think that's easier at 5 over 4 or 3 pi over 2. The quadrantal is easier. I just went ahead and picked the 4 pi over 3. So hopefully that helps with that question. We didn't have to go ahead and draw a rectangular graph, but we could have if we wanted to. We would just have to be careful because it has a period of only pi because of the 2 here. So we would probably have to sketch 2 periods of the function. Okay, let's see what I picked next. It spaced it out really nice here. Oh yeah, the top of the problem, I couldn't get it all to fit, but it was basically the same setup where we have a polar function from 0 to 2 pi, and on the interval, the graph has no holes, passes through at each point exactly one time, and as the angle theta increases, the graph passes through labeled points A, B, C, and D in that order. On which of the following intervals is the average rate of change, underline, of r with respect to theta equal to 0? That is our goal. Some other parts here that were important is that we are looking from 0 to 2 pi, of course, and that the graph is passing through A before it gets to B, and then I'm just kind of tracing these radius lengths, and then C, and then D, and then back to A. If we want the average rate of change to be 0, let's think about what we know with average rate of change. The formula we discussed back in Unit 1, our very first unit, was f of b minus f of a over b minus a. Right, very similar. It made you think of slope from Algebra 1. So what we would like if the average rate of change is 0 is that we basically need this fraction to be 0 over b minus a in order for the overall average rate of change to be 0. So we want one of these answer choices to give us outputs that are equal. So f of b, if f of b minus f of a, if they're supposed to subtract and give me 0, then I need those two outputs to be the same. Okay, so let's compare outputs here. The first one in the order mine are listed is A and C. Remember, you would look at these radius lengths from the origin. So from the origin to get to A, that is an output of 4. To get to C, that's also an output of 4. So this should be, just looking at the numerator of my average rate of change, this should be 4 minus 4 and give me 0. So this is the correct solution from A to C here. And we know that the denominator of this expression would not be 0 because we are at different radian measures here. So let me erase this though and just show you what it would look like if it's not the right one. So B to C, so we would be basically doing the output at the angle that gives me B. So that output, the radius length, or R length, was 6. At C, it's 4. Oops. Okay. So then we're going to get 2 divided by the change in the radian length. So not 0. If we checked again A to B, you could see the same thing's going to happen. Really, I guess we should talk about the order I subtracted these in, probably following the formula better. I'm probably getting a little bit too nitpicky now, but from B to C, I really should have started with like f of b here is going to be this value at C minus the one at B. So 4 minus 6, negative 2. And then we could test the same thing. Of course, A to B would be 6 minus 4, and then B to D, you might say, well, wait, these could be it. They're on the same axis, but if we looked at their outputs, we have 2 minus 6. So for those reasons, the other ones are not going to give us 0, and we can really just focus on making sure if we are trying to find the average rate of change of 0, that our numerator is 0. These outputs equal each other. There was one also on the assessment or the progress check where you had to calculate the average rate of change yourself, and you would be expected to use this formula to show your work and you would actually have an equation to plug into. Okay, a couple more. You'll notice a pattern. I picked another one where we're talking about where do the points lie? Are they getting closer or farther from the origin? I also made a little bit of change to the wording of this that y'all saw. So we'll talk through it. A polar function is given by r equals f of theta equals -1 plus sine theta. As theta increases on the interval 0 to pi over 2, which of the following is true about the graph of r equals f of theta in the xy plane? Okay, so you have a couple of choices here. One option is that you could make a table and see, we could test some values out. Maybe I'll do this a couple of different ways. Yeah, let's do it a couple of different ways and see. So let's go, I guess let's do table first. All right, so if we have our input being our angle, and what I would say here is let's go ahead and do 0 and pi over 2, and then let's pick something between them, but look at what we're plugging into. Let's be smart about this. Sine of an angle, and we have to do a calculation. It's going to be easier if we get a half here, so I'm going to choose strategically pi over 6 in the middle. And I'm plugging into -1 plus sine theta. All right, so -1 plus the sine at 0 radians. Sine at 0 is 0, so this is -1. I'm going to go plug in pi over 6, so -1 plus the sine of pi over 6. Let's see. -1 plus, oh right, a half. So I'm getting -1/2. And then if I plug in pi over 2, -1 plus the sine at pi over 2. Sine at pi over 2 is 1. Okay, so I get 0. So what this shows me, looking at the radius lengths, I'm starting at -1, moving to -1/2, then to 0. They are all negative values getting closer to 0. So I should expect that the points are going to be, now how does this equate? Just because they're negative doesn't mean they're necessarily below the x-axis. These are the radius lengths that I would be measuring in the first quadrant. So this is a polar graph right here. So let's see where they would be. I would have at 0, I would go -1. So from the origin, not towards 0. At pi over 6, rather than going a half in that direction, I'd be going -1/2 towards pi over 6. Oops. Let's put the -1/2 first. And then at pi over 2, back to 0. So because these were negative values, they were not sketched in quadrant 1, they were instead sketched in quadrant 3, being below the x-axis and getting closer and closer to the origin or the pole. So I'm picking that answer below, not above, not above, below the x-axis, getting closer to the origin. Now, if instead you didn't want to use a table, didn't want to think about the polar graph, if we think about this instead as a rectangular curve, our midline is at -1. The amplitude is just +1 because we would be trying to basically sketch -1 plus sine x in rectangular form here. our amplitude would be 1, and the period would just be 2 pi. If I put 2 pi at the end, sine starts at its midline, and if the amplitude is just 1, here's pi. So I'm going to start at the midline, reach the maximum first, and head back to the midline. Reach the minimum second, back to the midline. And then this would clearly show me that the function, I would still have to think about the polar graph here, but these values are all below the x-axis on this graph, but that means from quadrant 1 we're going to have below the x-axis also on the polar graph, but getting closer to the origin, which in rectangular form means I'm getting closer to the x-intercept, which is the origin or the pole in polar form. So whichever way makes more sense to you, I'm giving you options and hoping it makes a little more sense. Okay, I think I picked one more. I hope I'm not over-explaining. But right, is that even a thing? Who knows? All right, last one. It says, consider the graph of the polar function r equals f of theta, where f of theta equals 2 plus 3 cosine theta in polar coordinate system from 0 to 2 pi. Which of the following statements is true about the distance between the point with polar coordinates f of theta and the origin? So again, we're talking about distance between the point on the polar graph and the origin. We're looking at the r value. And here we go. I put this table again. We're trying to see that distance is increasing if our function is positive and increasing or negative and decreasing. And then if it's decreasing, we're looking for opposites here. Positive but decreasing, negative but increasing. So this one gave, I would scan my answer choices here and see I have 2 different intervals. Okay. And then let's read what it says. The distance for this interval, what is true? The distance for, hang on, sorry, I'm trying to remember what it just said that we're trying to do here. We're trying to see which of the statements is true about the distance between the point with polar coordinates. I feel like it cut off part of the answer choice. The distance, no, it's just a brain fart. All right, thank you for being patient with me. I could not find where it said if it's increasing or decreasing. It's in the very beginning of the statement. So this says the distance is increasing because, and then look at the reason, negative and decreasing for the function. So is that a right choice here? If the distance between the function and the origin is increasing, if the function is negative and decreasing, this one's potentially correct, negative and decreasing. This one says the distance is decreasing because the function is negative and increasing. So I'm going to rule this one out because we can't have negative and increasing. That means it's going to be getting closer to the pole instead, or closer to the origin. So look at your other 2 options. It says the distance is increasing, and then this one gives because the function is positive and decreasing on that interval. So I'm going to cross this out. Positive and decreasing, we see here, means that the distance would be decreasing from the origin, the distance of the function. So I'm going to cross this one out, and now we're trying to determine either the distance is increasing or decreasing. Let's read the reason on the last one. It says decreasing because the function is positive and increasing on the interval. Uh-oh, that's not going to work. So let's see. I feel like I've crossed out one now that shouldn't be crossed out. So the distance is decreasing because the function is positive and increasing. That definitely overall means increasing. Last one, positive decreasing means not increasing. Next one, negative and increasing. Oh, that does mean decreasing. All right. Well, it's not really worth doing the entire video, but be patient with me on this last one. So it takes a lot of very careful reading. Negative and increasing. There we go. Means that our distance would be decreasing. Okay, so big takeaway here. We have to focus on 5 pi over 6 and pi. And y'all, you don't even have something that we could test out in this interval. Like, what are we going to pick to plug into this function between 5 pi over 6 and pi? So instead, we're going to sketch a graph. We're going to sketch in rectangular form y equals 2 plus 3 cosine of x. I have a midline, an amplitude, and nothing with x, so the period is going to just be like the parent function, 2 pi. Hopefully this is going to give us everything we need to answer this question. There's 2, my midline. If my amplitude is 3, then that graph starts 3 above that at 5. And we'll go down to -1 at its minimum. And think about what we know here about cosine functions. They start and end at their maximum when we're just looking from 0 to 2 pi, the parent function does. So there's pi, where we'll see our minimum. And then between that, we will be reaching the midline, just trying to get kind of a sketch on here. Okay, so here's my graph, and we're looking between 5 pi over 6 and pi. So let's see what we have right here. We know right at this, where the graph hits the midline is pi over 2. Technically, this x-intercept, we don't know, but let's just see. We found an x-intercept earlier by setting the equation equal to 0. If you go to try to find this exact x-intercept, it's not a unit circle value, because it's when is cosine equal to -2/3. We would need a calculator to determine that for us. So instead, we're just going to have to look at the graph. This piece of the graph is below the x-axis, so it is negative, and it is also decreasing. So I'm going to go ahead and say negative and decreasing means that the distance overall is increasing on this interval. And we could see that if we zoom in on our graph and we look at this little section, these y values are getting more negative, therefore further from the x-axis and further from the pole in the polar form of the graph. I know it's a lot to think about for every question, but hopefully this helps with some of the trickiest ones. Again, I apologize for my misspeaking or misreading on this last one here, but hopefully the overall gist is correct. It really was me not reading carefully. So don't let yourself fall into that trap. Please let your teacher know if you need more help, and don't forget that there's also practice in AP Classroom and more resources posted on Canvas.